Welcome to Programming for Kids with Scratch 2. I'm Mike Lehman, and thanks for joining me. This series of half-hour shows uses Scratch to introduce computer programming to kids, about 5th grade and up, and curious adults too. You'll learn all about programming in Scratch in this series. It covers loop blocks, repeat, repeat until and forever, decision blocks including if and if else, procedure blocks, variables, lists, messages, events, clones, even microphone and video webcam input. I'll create many programs including games, storytelling, drawing pictures, and programs that demonstrate important programming concepts including objects, threads, and polling. This series is all about doing and shows the creation of all working programs from start to finish. Scratch is a great first programming language and can have children very quickly creating and presenting stories and creating fun animations, all while learning valuable critical thinking skills, problem-solving skills, and the fundamentals of programming without any of the confusing and detailed syntax. Scratch presents programming commands as single blocks that are easily snapped together to make programs with very little typing. Don't let the ease of Scratch fool you into thinking that there's little here. Scratch programs can do a lot of things. Very little math is needed to make fun programs, and I give the very few equations that I'll use in a handful of about 50 challenges. Scratch is free and freely available from the highly regarded university MIT. With your web browser, you can create, share, and save your Scratch programs if you want to. You can also look online at literally millions of shared Scratch programs, and if you like, you can join the Scratch community. You can just sit back and watch this show, or you can go to scratch.mit.edu, click on the Try It Out icon, and have fun learning how to program too. All of these video challenge lessons and more are available at my ProgrammingForKids.info website and at my ProgrammingForKids.info YouTube channel. The countdown timer at the bottom of the screen shows how long until a program is first run. This show number 12 introduces creating new blocks with 3 examples and creates a program to explore moving in a circle on the stage with the Move Steps block. I'll get started. In Scratch, we can create our own blocks. This is very helpful. I can create a new block called a procedure, then have the sprite use the new block in many different places in the sprite scripts. With procedures, I have one copy of the code so the procedure is easy to reuse. All the details for the procedures are in only one place, not in many places. My program is smaller, so it's easier to understand, and it helps me to organize my program so I can create larger programs to do more. I'll create a few procedures now for an introduction, but I'll create many more in the programs to follow. Procedures are fundamental to programming, regardless of the language. In an earlier challenge, I converted miles to kilometers. I'll make it a simple procedure now. I'll go to More Blocks, Make a Block, Miles to km, Options. I'll have one number coming in. That'll be the number of miles. I'll change number 1 to miles. I'm not going to worry right now about run with or without screen refresh. I have the define miles to km now. This will contain all of the code blocks to convert from miles to kilometers. This miles to km block will call the procedure. Right now it'll pass 1 for miles and expect the kilometer result somewhere. I'll go to Events, use when the green flag is clicked, so that now when the green flag is clicked, the procedure will be called passing 1 for miles. I want to save the number of kilometers in a variable, so I'll go to Data, make a variable, my km, for this sprite only. OK. Move it under the cat. I want to set my kilometers to miles times 1.61. I'll go to Operators, multiply 1.61. It's ready to run now. My km is the value of 0. When I click on the green flag, miles to km will be called. This procedure will be called. Miles will have the value of 1. 1 times 1.61 will be put into my km. I'll click the green flag. My km has 1.61. I'll change 1 to 10. Makes the math easy. And when I click the green flag, I should get 16.1 for my km. Green flag, 16.1. It's working nicely. I'm finished with this example. I'll remove my KM from the stage, get rid of the blocks. When I delete the define, the procedure will be gone. I go back to more blocks, it's not available anymore. So be careful removing procedures. I want my next example to show the different types of inputs or arguments passed into procedures. I'll make a new block, make a block. I'll call it example. It'll have 3 arguments. Options. It'll have a number, a string, and a Boolean type. Remember, Boolean values are logical values that are only true or false. I want number 1 to be steps, number 2 to be the message, MSG, and the third one, the Boolean, to say whether or not to hide the sprite. I'm not going to worry about run without screen refresh. Click OK. Move the define over, and I can call my new procedure with the example block. I want this procedure to move the sprite the given number of steps, display the message, and hide or show itself depending on whether hide is true or false. For my first example of example, I'll change the 1 to 100. Give the simple little message hi. I'll need to pass a Boolean type. I'll go to operators. I'll use equal. I want it to hide the first time, so I'll pass it true. 1 equals 1 is true. I'm going to move steps, so I'll go to motion, move steps, and I'll use the number of steps the procedure is given. The first time I run this, example is passing 100 for the number of steps, so the sprite will move 100 steps. I want to display the message. I'll go to looks, say. I want it to say the message. When I make the first call to example, passing hi, message has the string hi, so the sprite will say hi for 2 seconds. Then I want to hide or show the sprite depending on the value of hide. I'll go to control, if else. If hide, then I want to hide the sprite, else I want to show the sprite. On my first call, I'll pass true. Hide will be true, so the sprite will hide. The cat's going to hide, so notice that the cat is in the middle of the stage with x0, y0. I'll click on the green flag. The cat moves, says hi for 2 seconds, and hides. Now to make the cat reappear using this procedure, I'll copy the example. I want the cat to back up, so instead of 100 steps, which would go to the right, I want it to go minus 100 steps, so it'll go back to the center. Can't see the cat right now, but the x value is 100. The cat has moved to the right. For the message, I'll change it from hi to hi again. And I want hide to be false, so I'll change Boolean to be false. 1 equals 0 is false. I want the cat to reappear when I press the space bar. I'll go to Events. When the space key is pressed, I'll press the space bar now. It's running, it's highlighted. I didn't see the message. The cat is back in the middle though. The bug in this program, the problem with this program, is that say is not displayed if the cat is hiding. The cat has to be visible for say to be seen. So how can I fix this procedure to show the message when the cat is hiding, but also have the message displayed correctly when the cat is showing? If I move the say to after the if, then the message will not be displayed when I tell it to hide, because the cat will hide, then try the say message. I'm going to have to move the say inside the if clauses and put it in just the right spot. I'll duplicate it. I'll need one for the if and one for the else part. I need to say the message before the cat hides. I'll put it before. I need the cat to be showing before I can say the message. Now when I click the green flag, the cat will move. It's been told to hide. It'll say the message. Then the cat will hide. When I press the space bar, the cat will move back the number of steps. Hide is false. It'll show the cat. Then it'll say the message. This should work. I'll click on the green flag, get a high, and the cat disappears. Its location is at 100, 0. Good. I'll press the space bar now to make the cat return and display the message high again. There's my message high again. I'm finished with this example. I'll remove it, leave the green flag, ready for the next example. I want to draw polygons on the stage. I'll go to Pen, Pen down. Now the cat will draw on the stage as it moves around. First I'll draw a square. I'll go to Control, repeat. Square has 4 sides. Go to Motion. Cat will move around. Move 25 instead of 10. Turn to the right. Change it to 90-degree turns. And slow it down a little bit. Go to Control. Put a weight, but instead of a second, I'll use 0.5 seconds, a half second. Ready to run. Click on the green flag. The cat draws the square. I want to draw an octagon next. I'll copy the repeat loop. Save it. I'll change 4 to 8. Octagons have 8 sides. 25 steps is good. I only have to turn half the number of degrees for twice as many sides. Half of 90 is 45. This is ready to run. I'll click on the green flag. And I get my octagon. Now, in general, to walk around a polygon, the sprite turns a full 360 degrees to circle around it. To get the same angle for each turn, I'll divide 360 by the number of turns. The number of turns equals the number of sides. For example, the angle for a square is 360 divided by 4, which is 90. Squares have 90-degree angles. An octagon has the angle of 360 degrees divided by 8, which is 45 degrees. Don't worry if you don't understand the math. What's important to understand for this example is the turn 360 degrees divided by the number of sides. I'll create the procedure to draw the polygon. I'll go to More Blocks, Make a Block. I'll call it Draw Regular Polygon. For options, it has 1 number input, the number of sides. I'll change number 1 to sides. It'll be 4 for a square, 8 for an octagon. I won't check Run Without Screen Refresh. Checking Run Without Screen Refresh tells Scratch it doesn't have to update the screen. It does help it to run faster, but it can behave a little differently. I had a problem with the procedure to play notes from the sound palette, and I had checked Run Without Screen Refresh. So checking this may cause some other problems. If you really need your procedure to run faster and it works correctly with it, then you can check it. Otherwise, don't. I won't check it. I'll click on OK. I'll move my definition for the polygon procedure down. I'll copy the repeat loop. I want it to repeat for the number of sides. I'll drop that in. The move of 25 steps is fine. The turn for 90 degrees I'm going to have to change. I said earlier I need to turn 360 divided by the number of sides. I'll go to Operators, get Division, 360 divided by the number of sides. If the number of sides is 4 for drawing a square, the repeat will be 4 times, which matches this, and the turn will be 360 divided by 4, which is 90. That looks good. If sides is 8 for an octagon, it'll repeat 8 times, which is good. 8 divided by 360 is 45, which matches this loop. I don't need these repeats now. I'll move the define up here. I want to draw a square when the S key is pressed. I'll go to Events. When S key is pressed, scroll down for the S, go back to more blocks, draw a regular polygon. Squares have 4 sides. I'll copy this, duplicate. For an octagon, I want 8. Before I run this, I want to clear the stage. I'll go to Pen, Clear, and I want it to start at the origin. Go to Motion, go to, I want it to be back in the center of the stage at the origin, 0, 0. Change both the numbers to 0. Is this initialization going to have the cat at the center with a clear stage? Let's see what happens. I'll click the green flag, and it left a line on the stage. Why did it do that? When I clicked on the green flag, put the pen down if it wasn't down already, cleared the stage, then it moved. When the cat moved from this position down, it drew on the stage. That was being done after the clear. I'll move the go to up at the beginning. Now when the green flag is clicked, the cat will be moved to the center. The pen will be down if it's not already. Then the stage is cleared. See how well that works. Click the green flag. Clear stage. Good. Let's see how well this works. I'll press the S key. I've got my square. I'll press the O key for octagon. I've got the octagon. Looks like that's working nicely. I want to draw a few more polygons. I'll copy the blocks, duplicate, 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 duplicate. I want to draw a decagon. The D key, 10 sides. A triangle with the T key, 3. A pentagon with the letter P. Pentagons are 5-sided. And I'll draw a heptagon, 7 sides, not to be confused with a hexagon of 6 sides. I'll reinitialize, click the green flag, press the S key, the O key, D, T. See that it's highlighted. It stops highlighting when it's finished. I'll press the P key, and I'll press the H key. There are all the polygons, all sharing the same origin. This example helps to show how one procedure can save a lot of copies of code blocks. Instead of having 6 copies of the loop in these different places, I have just 1 copy and 6 simple calls to use the same code. I can make a loop to display many polygons. I'll go to Data, make a variable. I'll call it My Sides. Only for the sprite. Okay. I want to start from 3. I'll change 0 to 3. And I'll draw up through 12-sided polygons. Go to Control. Repeat until. I want to repeat until my sides is greater than 12. Operator, greater than 12. I want to repeat until my sides is greater than 12. I'll go back to Data, get my sides. Want to draw a regular polygon, I'll copy. And I'll pass my sides for the number of sides to draw. My sides will start at 3. It's not greater than 12. It'll draw 3-sided. Then I needed to increase my sides by 1. I'll get change, my sides by 1. Now my sides will start at 3, Draw 3-sided, then 4, 5, 6. Keep increasing, keep drawing until it's greater than 12. I'll attach it to the green flag. Move that out of the way. And for all this drawing, I'll get rid of the weight. I'll move the weight out. I'll move my sides down to the bottom. And I'll start the program. Going very fast, and it's drawn all the polygons. Looks a little like a seashell. I'm finished with this challenge. I hope you can see how procedures reduce copying code, get all the details in one place, not in many places, and help make programs smaller. I want to encourage you to play with these examples and create your own procedures. Try creating a procedure to convert Fahrenheit to Celsius, or a procedure to transpose a little melody with an integer input to raise or lower all of the procedure's notes. Use the play note command block in the sound palette. For example, the little melody may play the notes starting from middle C. If the procedure was passed the value of 1, it would play all of the notes in the melody one note higher. So you'll want to add the integer input to the procedure to all of the play note command blocks. Have fun with the challenge. In this challenge, I want a simple way to move in a circle around the center of the stage using move steps. As the sprite moves, it needs to turn towards the circle and hopefully stay close. The sprite will endlessly loop, moving 10 steps, then seeing if it's further away than the radius, it'll turn a little to its right. But how can the sprite know if it's too far away? The sprite will use distance too, to easily know if it's too far away. As you've probably been suspecting, some combinations of steps and degrees work, but many don't. One failing extreme has the planet flying away, and another failing extreme has the planet turning inward too much and flying into the sun. There are many unstable combinations, but that's part of the fun of this challenge. I don't need the cat. Right-click, delete. I'll need a couple new sprites. Space. Double-click on Planet 2. I'll move this over a little bit. It needs to get the distance to the center of the stage. I'll go to Sensing. Distance 2. I can get the distance to another sprite if I had one. I'll get another sprite. Space. Sun. I want it smaller. Go to Looks. Set size. I'll try 75%. That's better. I'll go to Motion. I want the sun in the middle of the stage. Go to 0, 0. And when the green flag is clicked, I want it to run. I'll run it. The sprite's at the center of the stage, so the planet sprite can get the distance now. I'll go to Planet 2 scripts. It can get the distance to the sun now. Sun. The distance is 87. I can make it a little farther away. Now the distance is 113. I'll get the loop. Control. Forever. Move 10 steps. Motion. Move. I'll need the if block. If the distance is further than the radius, operators, greater than, distance. I'll make the radius variable, make a variable, call it my radius, for the planet sprite only, okay. I don't want it on the stage, so I'll uncheck it. If distance to sun is greater than my radius, I need to initialize my radius. I'll initialize it to 100. If the distance is greater than 100, motion, want to turn to the right. 15 seems big, I'll try half of that, 7. The planet should start on the circle 100 units away. I'll get go to. X is 0, so it's in line with the sun, and Y is my radius. Duplicate. Turning the sprite will leave it pointing in a random direction when the program stops. I need it always starting pointing to the right as it is now. I'll get point and direction. To the right already. Great. I want this to run when the green flag is clicked. I'll run it now. The planet's wiggling a little bit in its orbit. I wonder what its path looks like. I'll stop it. I'll go to pen. I'll have it draw its path with pen down. I'll start with a clear stage. And pick the pen up so the go-to doesn't draw on the stage. Now when the green flag is clicked, stage is cleared, the planet's pointing to the right, radius is 100, pen's picked up, the planet's moved above the sun, the pen's put back down. Then it endlessly loops, moving and turning. I'll run it now. It's running. The orbit's a little braided. That's not surprising. I'm lucky this works. The steps and turns don't get the planet back onto the circular path, so the braiding seems quite reasonable. I can make this run a lot faster. Go to turbo mode. Now it's flying. Showing turbo mode up here. It's not quite stable. Oh, it's not. And it's... oh my. It's crashing into the sun. I'll stop it. That worked pretty well. I could turn off turbo mode by clicking on it again, but I'll leave it on. What if I'd like to know when the planet hits the edge of the stage? I can have the program stop itself when it does. If it's touching the edge, Control, if, go to Sensing. If it's touching the edge, I want to stop. Control, Stop All. I'll get the help block for Stop All. I'll use Stop All to be sure all the scripts are stopped, but Stop This script would work fine in this program since this is the only script running. Stop All can be helpful for stopping clones. I'll introduce clones later. And Stop Other Scripts in Sprite can be helpful to stop all the other event handlers that may be running. It would leave only the calling one running. I'll close Help. I'll run it now and it'll stop when the sprite is touching the edge. It's going. Getting closer, touched the edge and stopped. That did what it was supposed to do. I'm finished with this challenge. I encourage you to play with the program and get comfortable with distance to and stop all. Try changing the program. Try different combinations of steps and degrees and see if you can get a stable orbit. But above all, have fun with the program. I'm glad you could join me. You can review these and all of my challenges at my programmingforkids.info website and on my programmingforkids.info YouTube channel. I encourage you to try the things you've just learned and explore the extra challenges I've suggested. I hope you can join me for the other shows. Until next time, have fun being creative.